Hello everyone, welcome back. I hope you understood the concepts we discussed in the previous lecture on system of linear equations. I am Dr. Vikrant Yadav, Assistant Professor in Department of Mathematics at SR University, Warangal. Now, in the first part, we covered what is a system of linear equations, types of solutions, matrix representation and row operations and RREF, reduced row echelon form. But let me ask you a very important question. Do we really understand a concept until we solve problems on it? Obviously, the answer is no. So, in this part 2, we are going to focus completely on solved examples, their step-by-step explanation, how to approach problems in exams, and how to avoid common mistakes. In this session, I will not just solve the questions, I will also explain why are we doing each step, what is the logic behind them, and how can you think like a mathematician. So I request you to keep a notebook and pen ready and try to solve along with me. Okay, and you can pause the video whenever needed because this part is very important. This is where your actual understanding develops. So without wasting any time, let us start with the first example. Alright, so let us begin with our first solved example. This is a 2 cross 2 system, meaning 2 equations and 2 unknowns. Okay, so what do we expect here? A unique solution. Why? Because generally 2 lines intersect at exactly one point. Okay, so let us read the system very carefully. The system is 3x plus 2y equal to 12 and x minus y equal to 1. Always remember, the first step is understand the problem very carefully and clearly. Okay, now before solving this system of linear equations, let me ask you, what is our goal here? Actually, we want to find values of x and y that satisfy both equations simultaneously. Okay, and for this we will use the matrix method now. Okay, so our system is the augmented, and the system is to be changed into augmented matrix form. So the matrix reads as this matrix, that is 3 to 12 in the first row, 1 minus 1 and 1 in the second row. Okay, the left hand side, this part matrix is the having coefficients, and this one column, this one is having constants. Okay, now we look at the first column. The first column is 3 1. We want the pivot, the first element, to be 1. Right now it is 3. Okay, it is 3 right now, but look at the second row. We already have the value 1. Okay, so what will we do? Can anybody guess? We apply the row operation. Okay, that row operation is row 1 interchanges row 2. Now the new matrix is this matrix, where the first row is 1 minus 1 1, second row is 3 to 12. Why did we do that? Actually, swapping makes the calculation easier here, that is why we have done it. Now our goal is make the element, make this element 0. Which element? This 3 equal to 0 below the pivot entry. So we apply the operation, that is R2 changed to R2 minus 3R1. Okay, How will you solve that? Actually, in row 2, you can write row 2, I am saying 3 minus 3 times 1 equal to 0. Okay, because of this operation. Also, 2 minus 3 times minus 1 will be equal to 5. Okay, this is 2 and this becomes plus 3. Then 12 minus 3 into 1 will become 9. Okay, so our second row becomes this 0, 5 and 9. Okay, next is, now we'll go to row 2. Okay, row 2 in which the first non-zero entry is 5. This is the pivot entry. We want it to be 1 here. So we shall divide row 2 by applying the operation 1 by 5 R2, the row 2, which means that I have multiplied the whole row 2 with 1 by 5 so that this pivot entry becomes 1. Okay, so this entry becomes 1, this becomes 9 by 5. Now make 0 above. This one is our next task. So we can simply add row 1 with row 2. Okay, or you can say that we have applied the operation R1 changed to R1 plus R2. So this term becomes 0. Okay, so the final matrix is 1 0 14 by 5 0 1 9 by 5. Okay, now this is reduced row equivalent form. From here we directly read the values x equal to 14 by 5 and y equal to 9 by 5. Let us verify. Okay, let us verify this is in this step whether these values are true or not. Okay, put back these values into its original equation. So here we are having y equal to 9 by 5, x equal to 14 by 5. Put these values in the original equation, that is 3x plus 2y equal to 12. So 3 into 14 by 5 plus 2 into 9 by 5 equals to 12 only. That is equal to the right hand side. Also in the second equation we are having x minus y equal to 1. So it will be 14 by 5 minus 9 by 5 and that is going to give me equal to 1. So these values are true. Okay, valid result. Therefore, this solution is correct. So we conclude from this that this system has a unique solution. Okay, that is equal to x equal to 14 by 5 and y equal to 9 by 5. And what it dramatically means is that the two lines are intersecting at exactly 1 point. Okay, they are intersecting at exactly 1 point. So now let us move to the next example. So in the last example, we saw a system with a unique solution where the lines intersect at exactly 1 point. Now we will look at a different type of system. This is a very important example, okay, where we see the case in which no solution exists. Let us read the system. The first equation is x plus 2y minus z equal to 3. Second equation is 2x plus 4y minus 2z equal to 8. And third equation is 3x minus y plus 2z equal to 5. Now at first glance it looks normal, but let me show you something interesting. Look at equation number 2. Okay, compare it with equation number 1. If I multiply equation 1 by 2, say equation 2 will 1 will become 2x plus 4y minus 2z equal to 6. Okay, but equation 2 says that it is equal to 8. So left hand side is same, but the right hand side is different. What does this mean? It means something is wrong here, right? So this is a hint of inconsistency here. Now let me ask you, can two equations have same left hand side but different right hand sides? Actually no, because that would mean 6 equal to 8, but that is not possible as they are not equal, right? So now we convert this system to augmented matrix, in which the first, this left hand side part is coefficients matrix, and this right hand side part 3, 8, 5, this column is constants uh, column matrix. Okay, now we first simplify this matrix. Okay, we make 0 below pivot entries. The first pivot entry is 1. We need to make 0 below this 2 should be 0, this 3 should be 0. So we apply the operations R2 change to R2 minus 2R1. Okay, so this part will become 0, and this part, okay, and this 4 will become 2 minus 2, that is 2 into 2 minus 2 into 2, that is 4. This will also become 0. Again, this minus 2 will become 0, because we will be writing here minus 2 times minus 1. Okay, that will become 0 only. Then this 8, it will be 8 minus 2 times 3. Okay, that will become 2. So the final matrix, final row number 2 is this one, 0, 0, 0, and then 2 at the end. Now we applied the other operation as well, that is R3 changed to 3 times R1. Okay, so this 3 will become 0 here, 3 will become 0, and this minus 1 will become minus 1 minus 3 times 2. Okay, that will become minus 7. Okay, and this 2 will become 2 minus 3 times minus 1, that is 5. Okay, and this 5 will become 5 minus 3 times 3, that is equal to minus 4. So here is the final matrix after applying these two operations. Okay, then we see that the row 2 becomes complete in 0 of this kind. Okay, row 2 is of the type 0, 0, 0, and then 2. Correct. So we shall interchange, we will rearrange the system with these equations in a better way. We are applying the operation, this one R2 interchange with R3, so that the final matrix becomes the way that you are looking at the screen. First row reads 1, 2, minus 1, 3. Then second row reads 0, minus 7, 5, minus 4. And third row is 0, 0, 0, and 2. Okay. Now, look at the third row very carefully in the last matrix, this matrix. Okay. It is 0x, you can write here as 0 into x plus 0 into y plus 0 into z equal to 2. That is giving you 0 equal to 2 actually. It is not possible, right? This is called contradiction. It means There is no value of x, y, or z that can satisfy this system of linear equations. So what we conclude here is the system is inconsistent. Okay, what it geometrically means, each equation represents a plane. Okay, all the three equations represent a plane, but these planes do not intersect at a common point. So there is no solution. Okay, also one more important theoretical result is there. Since the rank of the matrix A is not equal to rank of augmented matrix AB, okay, rank of A is 2, rank of augmented A matrix augmented AB is 3, so system is inconsistent. So we conclude from this example that the system has no solution and this is inconsistent system. Okay, I hope you understood this very well. Now let us move to the next slide. Alright, so till now we have seen first case unique solution, second example in which we saw no solution case. Now it comes to third and the final case, that is infinitely many solutions. This is a very interesting case and also slightly tricky, so pay close attention. Let us read the system. The given system is, first equation is x plus 2y plus 3z equal to 6. Second one is 2x plus 5y plus 4z equal to 11. And third one is x plus 3y plus z equal to 5. That is 3 equations and 3 unknowns. Normally we might expect a unique solution here, but here something different will happen. Have a close look. Let me ask you, does number of equations always guarantee unique solution? Actually no. Okay, it depends on the rank, not just the number of equations. So let us construct the augmented matrix from this. The augmented matrix is having in the first row 1, 2, 3 and 6, second row 2, 5, 4 and 11, then it is third row 1, 3, 1 and 5. Now we simplify. Okay, we need to make 0 below first pivot entry. First pivot entry is this first non-zero element in the first row. Okay, so we apply the operation row 2 change to row 2 minus 2 row 1. Okay, so the elements become 2 minus 2 into 1 equal to 0, then 5 minus 2 into 2 equal to 1, then 4 minus 2 into 3 equal to minus 2, then 11 minus 2 into 6, okay, that is equal to minus 1. So our row 2 becomes of this form 0, 1, minus 2 and minus 1. Okay, again we apply the operation row 3 change to row 3 minus r1 row 1. Okay, in that case it will be coming out as 1 minus 1 into 1, that is equal to 0, then it is 3 minus 1 into 2. Okay, that will become 1, then it is 1 minus 1 into 3, that is equal to minus 2. Okay, next one is 5 minus 1 into 6, that is equal to minus 1. So our row 3 becomes 0, 1, minus 2 and minus 1. Okay, now Carefully look at row 2, okay, and then row 3. You will find that both of these are exactly the same, okay. Then you apply the operation row 3 change to row 3 minus row 2. So this row 3 becomes completely 0, okay. So the new matrix is, as you can see on the screen, it is having row 1, row 2, non-zero rows are row 1 and row 2, and third row is 0, completely 0. Now, this is very important. One full row becomes 0, that means we have less independent equations. So rank is less than the number of variables basically. Okay. Now, let us make it a little simple. Apply the operation row 1 change to 2 times row 1 change to row 1 minus 2 times R2, okay, and solve it. Then it will become 2 minus 1 into 2 times equal to 0, okay. We are subtracting row 1, row 2, row 1, we are doing the operation row 1 minus 2 times R2. It will become 2 minus 1, 1 minus 1 times 2 equal to 0, okay. So it becomes, first row becomes 107, that is 8, okay, and this second row is 0 1 minus 2 minus 1, third row is completely 0. So it is now very important step in which column has no pivot, okay. Column 3 is there which is having no pivot. So in that case, this column will behave as that it will be having a free variable. This variable z will behave as free variable. Let us assume z equal to t, okay. If we assume z equal to t here, then where t is any real number, okay, then this is called a parameter. Our t will be called as parameter, okay, it is a real number only. From second row, the equation is y minus 2t equal to minus 1. Substitute z equal to z equal to t in this, so it will become y equal to 2t minus 1. So now y is also in terms of t only, the parameter, okay. Again, from row 1 you are having the equation as x plus 7t. After replacement of y and z into it, you'll get x plus 7t equal to 8. So x becomes 8 minus 7t, okay. So the most important step, the solution becomes, we are writing the solution now. Then the solution is x, y, z column, okay. So x is, we have written it like this way, okay. First of all, we write x, y, z, this as, okay. X is 8 minus 7t, y is 2t minus 1, and this z is t basically. So we'll separate them out, the constants on one side and the, okay. So it is 8 minus 1 and 0 plus t times minus 7 to 1. That is the parameter. Now here, this t is a particular solution, okay. This is a particular solution, and the solution here, this one is general solution, okay. If t equals to 0, then it becomes a particular solution. So we can conclude that this system has entirely many solutions depending upon the value of t. And what it geometrically means, it means that solutions form a line in 3D space, Okay, and they form a line in 3D space. I hope this example was useful to you. Now let us continue with the next slide. Alright, now let us move to a slightly more advanced example. This is a 3 cross 3 system, meaning 3 equations and 3 unknowns. And in this, we expect a unique solution because this is a full rank system. Okay. Now, let us read the question carefully. The first equation is 2x plus y minus z equal to 8. Second equation is minus 3x minus y plus 2z equal to minus 11. Third equation is minus 2x plus 4 plus 2z plus y plus 2z equal to minus 3. Now our goal is to solve this using Gaussian elimination method. Okay. Now let me remind you, Gaussian elimination means we convert the system into upper triangular form and solve that step by step. Okay. So let us first convert it into augmented matrix. The first matrix here, this is our required augmented matrix. Okay. In which the left hand side till here it is coefficients matrix, this one is constants vector or column matrix. Okay, then we make first pivot equal to 1. This 2 here should be equal to 1. Okay, so that the calculations become easy. Okay, so we multiply row 1 with 1 by 2 times row 1. Okay, we multiply the row 1 with half, basically you can say this. So it is 1, this will become 1, this is half, and this is minus half, this becomes 4. Okay, now our task is that we make zeros below this pivot entry, this entry 1. Okay, below this we need to make 0, that means this should be 0, this should be 0. So we apply the operations row 2 change to row 2 minus 3 plus 3 times row 1, and row 3 change to row 3 plus 2 times row 1. Okay, so the operations, let me show you one. For this operation I'm solving it. This is minus 3 times plus 3 into 1, that will become 0. Similarly, second element is minus 1 time minus, this is plus 3 into half. Okay, that is equal to 1 by 2. Okay, similar way you can find the other value as well, which is equal to half here. So next it will become 1 there at this place. Okay, then you can similarly apply the second operation, that is R2 change to R3 minus R3 plus 2R1, and you will get the row as 0 to 1. Okay, and 5 at the end. Now we make 0 below the second pivot as equal to 1. For that we multiply this second row with 2, that is row 2 is multiplied with the value or the real number 2. Okay, so this second row becomes 1, 1 and 2. Okay, now our task is to make 0 below this pivot entry, that is this 2 should be 0 here. So we apply the operation row 3 change to 2 times row 2. So it will become, third row will become 0, 0, minus 1 and 1. Correct? Next is row 3, in which the entry is minus 1 here. first non-zero entry is -1. Okay, now we make the pivot this entry equal to 1. So it is going to be equal to, we shall multiply it with -1 so that it becomes 1 here. So the final matrix reads as 1, 1 by 2, -1, minus half, 4 in the first row, then 0, 1, 1 and 2 in the second row, and then 0, 0, 1 and -1 in the third row. Now we start solving from bottom. Row 3 gives us z equal to -1. Okay, row 3 will give us z equal to -1, and then this row 2 changed row 3 minus row 2 minus row 2 minus row 3. So it will give you y plus 0 equal to 3. Okay, sorry. Okay, we'll try to solve it again. Okay, so actually from this step you are getting z equal to -1. So from second row you are getting y plus z equal to 2. Z is here -1, so it will become y equal to 3. Again from first row you are getting x plus 1 by 2y minus half times z equal to 4. So that is going to give you x plus half time y, that is 3 by 2, and it is going to give you minus half equal to 4, that is plus half actually. So it will become x equals to 2. Okay, so x is equal to 2. So our final answer is x equals to 2, y equal to 3, z equal to -1. We can check these values whether they are correct or not by putting them in the equations. Okay, for example, if I put value of x, y and z in the first equation, I am getting 2 into 2, 3 into 1 and -1 into minus of -1, that is equal to 8. That is equal to the right hand side. Other equation you can verify easily, that will be also equal to -11. Third also you can verify. Okay, so hope you are getting it, and these concepts are and questions are helping you to understand this topic, system of linear equations, very easily. If you found this video helpful, don't forget to like, share and subscribe to the channel. Thank you.